Today's lesson is about definite integrals. First of all, let's do this problem. Find the shaded area. Let's work out this linear function. Y equals slope from here go here. That's rise over run. Here is 8. This is 4. So it's 2x. The b y-intercept is 1, so you have y equals 2x plus 1. For this linear function, the shaded area, you could say the shaded area is a trapezoid. Therefore, here is 1. This will be 9. The height is 4. You will use area equals 1/2. 1 plus 9 times 4. So you get 20. This is a unit square. Let's check this integral. We learned integral of 2x plus 1 dx. No number over here. We call this is a indefinite integral. If we put a number that's from 0 to 4, it's just like from here, 0 to 4. Then we call this integral is a definite integral. We will work this out as an indefinite integral first. Then you need to plug in 0 and 4 separately, then do the subtraction. Think about indefinite integral. We did 2 times x squared over 2 plus x plus c, so that you get the x squared plus x plus c. Now, we will do exactly the same thing, but c, we don't need a c. When we do the subtraction, c is gone. So you will put the x squared plus x, then bracket, put the 0, 4. Then you substitute the 4 for x. You will get 4 squared plus 4. Then subtract. Here is a subtract. Substitute 0 for x this time. 0 squared plus 0. You will get 20. Let's analyze this integral and also the shaded area. Both got the 20. So you could think there must be some relationship between this definite integral and this shaded area. Yes, there are some relationship between them. They are equals to each other. In other words, definite integral from 0 to 4 of 2x plus 1 dx equals this shaded area under the curve. Here's the definition. If f of x is a continuous positive function on an interval from a to b, then the area under the curve between x equals to a and x equals b will be written as this. If indefinite integral of f of x dx equals capital F of x plus c, then for the definite integral from a to b of f of x dx, you will get this capital F of x. Then we write down bracket from a to b. Then you substitute b for x, get the f of b minus f of a. Substitute a for x. This is the formula for definite integral. According to this formula, we can get the property 1 of a definite integral. What if we have an integral from b to a, f of x dx? Then you could say we have a capital F of x from b to a, that equals f of a minus f of b. Because f of b minus f of a, that equals negative parentheses f of a minus f of b. So we have an integral from a to b f of x dx equals negative integral from b to a f of x dx. This is a reversed interval property of a definite integral. For the definite integral, this will be the formula. For this a and b, we call a, b are interval. For this a, we have another name, lower limit. For this b, we call upper limit. Let's explore another property of a definite integral. Think about integral from 0 to 2x to the third power dx. According to the definition of a definite integral, we know this is the curve x to the third power. From 0 to 2, it's from here to here. So the area under the curve will be this. This is meaning the integral from 0 to 2, x to the third power dx. For second one, the definite integral from 0 to 1 of x third power dx, it will be this. Let me use this color, red one, to show. This part means integral from 0 to 1 x third power dx. For this, integral from 1 to 2x third power dx, it will be here. This is a definite integral from 1 to 2 x third power dx. According to this diagram, we could say the definite integral from 0 to 2 x third power dx equals definite integral from 0 to 1 x third power dx plus integral from 1 to 2 x third power dx. You could say x third power. It's all x third power. Only interval change. This is from 0 to 2. Here is from 0 to 1. Then from 1 to 2. So we have the second property of a definite integral. We call this is an additive interval property. So you have a integral from a to b f of x dx. It will be equal to from a to c, then from c to b. According to this definition, this is a keyword, a continuous positive function. Then this definite integral means the area under the curve. What if the function is not a positive function? It's a negative function, then what's gonna happen? Let's explore definite integral from -2 to 2x third power dx. This function is y equals x to the third power. If we put this into a graphing calculator, your answer will be 0. What happened if a definite integral only means area? How did we get 0? When we use definite integral from 0 to 2x third power dx, that means this area under the curve. If you put into graphing calculator, you will get 4. For this definite integral from -2 to 0 x third power dx, then when you put into graphing calculator, you will get -4. In other words, for continuous positive function, the definite integral is a positive value. For continuous negative function, the definite integral will be negative value. Therefore, we can draw a conclusion. Definite integral is assigned area under the curve. When the function is a continuous positive function, then the definite integral is a positive. But for those continuous negative function, the definite integral will be negative value. Besides these two property of a definite integral, we also have a linearity of definite integrals, like this. If you have a constant number k multiplied by f of x, you can take this k outside. If the function is addition of two functions, you can separate them. If the function is a difference of two functions, you can separate them also.